Hello, let's look at how to get the linear equation from a graph instead of getting it from a table. So we have question 8 here from page 240 of your text. The graph shows the relationship between the cost C in dollars and the mass M in kilograms of pears. Okay, so mass is our x, cost is our y-axis. What is the linear equation? Well, I look at this graph and right away I'm looking for slope. I don't see that the slope works out nice. If this goes down, it goes down 2, and then there's some fractions that could get in the way. So another way to solve this is using our general equation of our line. So y is equal to mx plus b. So I can use this to solve our equation. Okay, so I just pick a value of x and a value of y, a nice set of ordered pairs. So I look at the graph. This doesn't fall nicely as an ordered pair. This doesn't fall nicely as an ordered pair. Neither does this one. But aha, this one does. So I look at this ordered pair and I'm going to pick it. So when I have 4 kilograms of pears, I'm going to pay, or it'll be a cost of $7. So 4 comma 7 gives me my ordered pair. So I'm going to use that for mx plus b. Another thing I need to look for is my b-intercept, or where the equation crosses the y-axis. Now, if I think about it in logic, it makes sense that if I had no pairs, I wouldn't have any cost, right? But just to double check, I can do something to the graph called extrapolate, which means I just take the line of the graph and I just draw it down, okay? And if I were to line it up, that's not really good there. Let's try again. I take this point here and I draw it, and I realize if I extend the graph down, it's actually going to cross at 0, 0, which makes sense. So I rewrite this as y is equal to mx plus 0. Okay, so I'm not going to have a constant in this example, or a b value. Okay, next thing I can do is I can then substitute in my x and my y. So for my x and my y, I chose 4 and 7 because it's nice numbers, right? So this is my x is my 4 and my y is my 7. When I write ordered pairs, it's always x comma y with round brackets. Okay, so it would be 7 equals m, because I'm going to solve for m, and my x is going to equal 4 plus my 0, which I don't even have to write. So now I have this algebraic expression I need to simplify. How do I get m alone? Well, I have to get 4 to the other side. It's technically m times 4, so what's the opposite of multiplication? It's division. So if I divide both sides by 4, I'll get 7 over 4 is equal to m. So my slope, or if I rewrote my linear equation, would be y is equal to 7 over 4 of x. Now, 7 over 4 doesn't really make sense, right? Because I'm dealing in cost or dollars. So I can actually change this to a decimal. So 7 divided by 4 becomes $1.75, or 1.75x. So this is my linear equation for this question. And now I can use my linear equation to solve b and c. Okay? So I'm just going to rewrite it here. So y equals 1.75 times x. Okay, and question B says, how much could you buy for $5? So if I had $5, how many kilograms of pears could I buy? Okay, so I know that my cost is my y value, and I'm trying to solve for x. So I substitute the 5 into the y spot. So instead of y, it becomes 5 equals 1.75, or my slope, times x, because I'm trying to figure out my x. So again, it becomes another division question. I divide each side by 1.75. 1.75. I'm going to do that in my calculator. My x will then equal, so I'm just going to rewrite it again, y, or pardon me, not y, x will equal 2.86 kilograms. Okay, so if I go back on the graph and I actually look at that, if I drew a line at $5, and I go across to the graph and I touch the red line, and if I draw another line down, I roughly get about 2.85. So I know my answer makes sense, right? So what I did here was called interpolate. Oh, I'm writing. Sorry. Right here, word interpolate, meaning that I looked and found a value on the graph that was between two data points. Okay, I know that my data points are here and here because they're drawn as circles. The distance between the line is drawn in. So technically this is an approximation. It's not an actual real value. Anything could happen on a graph from here to here. It might not be a linear line here. Maybe something happens here that causes the line to all of a sudden change course and go up and down and do something silly, right? So by drawing this smooth red line, we're guessing what's actually happening here. And we only know for sure what is happening at our actual data points that were given on our graph. Okay? Now, the opposite of interpolate is extrapolate. And that means when you take a graph and you extend it on either end. So I don't know if I can actually go all the way down to 0 here to buy. I can't have 0 pairs. Well, if I had 0 pairs, I'd have no cost. Or I don't know what happens if I extrapolate off the graph to figure out maybe if I buy over 5 kilograms of pairs, maybe the cost changes and maybe it's not a nice linear or straight relationship anymore. So there's two things you can do with a graph. I can extend it or extrapolate it, or I can interpolate it, which means to find values in between two actual points on the graph. Now, is it appropriate to do that, is what C is asking. Well, it depends on the situation. I can do that for mass, because mass is a continuous set of data, okay? Meaning that it goes on after decimal. Something that's discrete, like number of people, it'd be really hard to go between 2 and 3 people on a line, because you can't have 2 and 2/3 of a person, right? And same with cost. Cost is also continuous, so I don't have to worry about going between dollars and cents. So it's okay in this example unless something changes. So like I said, if I was extrapolating and the cost changed after 5 kilograms, then my data wouldn't be correct. So it depends on the data and it depends on the information you're giving in the question if it's actually appropriate. I think it's appropriate here to interpolate the graph. Extrapolate, like I said, it depends on the information given. I hope this helped. Ask me any questions.